All right, everyone, good morning and welcome to our webinar, Agile Analytics for Actionable Intelligence. My name is Sarah Lynn Bruner and I will be your host for today. And today's presenter is Praveen Kumar. Praveen is an enterprise data architect at Infostretch and carries extensive experience in distributed computing, big data analytics, and machine learning. While working at Infostretch, Happiest Minds, HCL, and Sapient Corporation, he has led multiple full-cycle implementations of using these stacks to deliver business intelligence insights to varied business problems for clients in several industries. And before we begin, let me review some housekeeping items. So first, this webcast is being recorded and will be distributed via email to you, allowing you to share it to your internal teams or watch it again later. Second, your line is currently muted. And third, please feel free to submit any questions during the call by accessing the Q&A button, the navigation in the top center of your screen. We will answer all questions towards the end of the presentation. And also, during the presentation, we encourage you to engage in the poll questions to maximize your experience during this time. We will do our best to keep this webinar to the 45-minute time allotment. And at this time, I'd like to hand the presentation over to Praveen.
Thank you very much, Sarah. Hello and welcome, everybody. First of all, I would just like to make sure, because of the initial logistics problem. Sarah, can you hear me?
Yes, we can hear you just fine. Thanks, Praveen.
Right, so I'm going to take the control. So, I'm Praveen, and I do everything data for a humble living. Overall 15 years of computing, but from past 5 years, I've been doing data engineering and data science in a selective, intensive mode rather, where I'm totally focused on data analytics project, before which I was pretty much a generalist in technology field and ended up being kind of everywhere until I realized that I kind of belong here. In retrospect, it was on a badly planned career. So out here in Infostretch, I'm part of an extremely dynamic team comprised of some smart and creative engineers working on some innovative solutions targeted towards big data and machine learning solutions for different clients. And during the rest of the presentation, you're going to see me giving references to a lot of work that's brewing in our labs that we are trying to implement for different clients. So because we have a rather comprehensive topic at hand, so I would come to the point straight away. Today we're going to talk data, right? Don't be too serious about the title of the webinar now that you are here. It ends there. Not really. So let's have a look at what we're going to cover, right? We'll try to cover the entire rainbow from start to finish, from traditional data methods to the most contemporary and creative usage of data, just kind of bringing most surprising changes in the way we're going to live the lives. So the part one, we're going to be dealing with some of the traditional data solutions, which I'm sure you guys are mostly familiar with. We're going to talk about what is that, why is it still relevant, and how it's being done to a little extent. And we're also going to talk about some of the business contexts where it fits in. But because this is something which is extremely familiar zone, we're not going to spend much of the time because we have something very interesting waiting for in part two and part three. In part two, we're going to talk about the big data analytics, which is one of the most happening thing at the moment. Actually, everybody of you must have come across that, but we're going to capitalize this particular opportunity to know more about that in the kind of details it deserves. And while we're going to move on to that, lastly, we're going to end up with some very interesting and creative usage of data in how it statistically learns, and we're going to incline more towards the machine learning part and the AI part, and some of the very interesting stories are going to be discussed out there, right? So let's move forward, shall we? And right, I'm going to go on to the next slide. There you go. So that's right. So I think it's only important to discuss what is data analytics. So just for the academic reason, am I going to read the definition of what data analytics is all about? Data analytics is the process of converting data into useful information. No brainer for that, but there are multiple methods, and this is just the start. A typical data analytics process, follows this cycle, precisely starting from the top box, which is acquire, explore, visualize, test, and study. We have data spread across, in normal circumstances as well. We have data which resides in small pockets within the organization. What we do is we acquire that and, bring it to a state where we can do some sort of analysis on the top of it. Because until we do that, we cannot do any kind of visualization on the top of it, because it's only then it's going to make sense. And then we're going to test that particular thing to make sure that whatever visualization we've done, that's meeting the purpose itself. And, that's going to help us, analyze the information that initially we started acquiring, actually. So this is a straightforward process. Many of us would have done it. I think we can clearly remember some of the pay slips information, some of the HR-related information, and the logistical information many times we would have done using some of the conventional tools that we're going to talk about in the next slide. And this is one of the most popular tools, which is Microsoft Excel. And the reason why it's most popular is because it allows us to do so many things in this same platform. It gets installed on any kind of system, is handy, and it gives us the opportunities to do data explorations. Pivot tables, one of the most used thing, actually, for enabling us to do some out-of-the-box, analysis, which it can offer. We can do quicker calculations and charting, not spending too much time on it, with an assumption that this is extremely familiar, right? And the next level of analytics, as many of you would have recognized, are the databases, actually. And this being called as traditional is still relevant. They are the computer systems designed to store and organize data for transactional and analytical purpose. And let's get into details of what are the kind of databases we were talking about, actually. So normally databases are relational in nature, which means that we normalize the data, right? We tie the data around entities, and we create relationships between them. So the information of an employee can go into one entity. The information about employees' personal details can go in another table. The information about employees' activities can go in another table itself. So what we are doing is we are creating logical boundaries of information which is going to be interconnected, and such a system is called RDBMS, which is Relational Database Management System, quite used, application or maybe, a system for containing information and also allowing us to run some ad hoc queries on the top of it, or else use that as a backend for many applications itself. Analytic and the examples for those RDBMS are many, like MySQL, and SQL Server, and Oracle normally comes up with many such databases. The second category of the databases is analytical databases. Now, these are some specialized form of database which are released by companies like Oracle and some other organizations which go on to release the products like Informatica and all that stuff. So now, the different thing about these analytical databases is the way the data is being kept there. Like I told you initially, classic RDBMS, which happens to be in the first column, works on the concept of surrounding the data around entities and interconnecting them. But for analytics, we would rather keep all the data together, because we would like to do analysis which might incorporate data from multiple pockets to make it easy for you to understand. That kind of data is called denormalized data, and It's more human oriented. Think of it like, if your data is kept in 6 different branches, and if you have to get it at one place, it's going to be hard work for you, So anything to get it at one place. So the idea of analytical database is that you keep all the data together in a form which doesn't take much for the person who's trying to do analysis to get it together, So if it happens to be together, it's going to be far more easier to analyze. There are simple queries, and you're going to find these kind of analytical databases getting used mostly in the data warehouse and data mart kind of situation, actually, right? And the third category is going to be a NoSQL, and there can be an entire presentation based on NoSQL, but the way I'm going to tell you is that it's a kind of database which gives you a lot of flexibility, and it is distributed, which means that it is quite capable of handling huge scales of data. So if you have plenty of information of your call records and all that stuff, let's say a telecom company which has got excessive number of call records, or a hospital which has got too many electronic medical records, what they can do is they can store that particular data in a distributed fashion, right? And the flexibility part comes in because what happens in normal databases is that you create a structure first, and then after that you put the data which is in conformance with that particular structure. But here in NoSQL, you can move the data in there, and it will allow you to store the data which may not be in a consistent form, but still you can end up running queries on it, doing analysis on the top of it. So I think these are the different categories of databases that all 3 of them, they have their own business context, actually. So I'm going to move forward. Like I told you, this is the first section, mostly familiar stuff. We're going to move a bit faster on that. So the one thing that I talked to you about data warehousing, when we talk about data analytics, this becomes extremely crucial, because this is the way the world was moving forward before we came across some of the most contemporary technologies like big data and machine learning. Expensive stuff. A lot of bigger companies, they invested millions of dollars in these kind of solutions until they realized that this has limitations, which is where we have some breakthrough technologies coming in. So you can think of data warehousing as a kind of superstore which has got different shelves, right? But everything that you need to buy, you can get under one roof. That's what data warehouse is all about, right? So some organization might have different areas where the data comes in. Like, for example, an organization might have financial data, logistics data, marketing data, organizational data, and a number of data. If you go on to decide to make a warehouse, the first thing that you're going to do is you're going to bring all that data in one place, so that collectively you can analyze that, right? So think of it like a superstore, but still it has different alleys and different shelves where the respective data is going to be kept, actually. And that is the reason why the icon, a non-technical icon, has been used out here. Right. Now, but it can't be complete unless I give you a visual representation of what happens normally. The best way to understand this diagram is to imagine a posh and swanky, control room of a top company where the C-level executives are sitting, and they're, lounging over huge, shiny dashboards where all the reports are coming. Think of it like the rightmost area where it says strategic decisions, business monitoring, and targeting customers. But how do those reports come by? What happens is, in the leftmost column, as you can see, the data can come from disparate sources. It all comes down to one single container. It's logically represented out here as a back office, which simply means all the data comes at one point in a data store. And then we have to analyze it, usually done by the front office, using some of the transformations. In technical parlance, it's being called as ETL, because we are extracting the information from different sources. We are transforming that in order to make it conducive for the consumption reports, and then we load it on, right? So That's what it is. But essentially what it means is that you get all the information together and enable some of the vital, important reports out for the consumption of the guys who are on the top of the strategy. They want to take some decisions. That's what it's all about. That's what it says. By collecting data from multiple sources, organizing it into simple structures, analysts and programs can leverage it for better decision making. So let's take this opportunity to get into the details of big data analytics solution, and it logically follows the area that I described to you at the moment. We talked about the traditional data solutions and all the limitations. What was the limitation? The limitation was largely in terms of scale, right? In past 5 years, the world's data has been doubled, and a lot of challenges have come in as far as the scale of data is concerned. So let's talk about it and what are the ways forward. Let me just bear with me for a second. And right, there you go. So right. So what is big data? In simple words, it's a lot of data, And to explain it in empirical terms, must refer to terabytes or petabytes. And trust me, as we talk now, these terms are also quite elementary at the moment. Actually, the dimensions have gone on to the next level. Actually, so if you're talking about this kind of data, yeah, we are talking about big data. Well, there are some other things as well that we're going to speak about. Big data is the term for collection of data sets so large and complex that it becomes difficult to process using hands-on database management tools or traditional data processing applications like we spoke about in the previous slides. And it's a kind of ecosystem which involves so many things actually that we're going to take opportunity to understand in the coming slides. But if I have to mention it, we have challenges related to capture, curation, storage, search, sharing, transfer, analysis, and visualization, and that's too much of it. You can pretty much, take that as simple English because we have some other slides to come back. I believe I've gone a bit further. Right. So just to give you an idea, when we say big data, when we talk about terabytes and petabytes, and what are the kind of challenges. So I'm going to give you an example of a couple of organizations which are already dealing with this kind of data. And trust me, this is just when we talk about these organizations, we're just going to scratch the surface, right? So just to give you an estimate, Facebook at the moment, it deals with 300 petabytes of data. And I'm sure this figure also, as we talk, is going to be more, arcane. It is dealing with the processing of 600 petabytes of data every day. Over 1 billion users per month, and rest of it you can read. I could have put in any kind of numbers, and trust me, you had no other option but to believe it. But trust me, these are real numbers. If you talk about NSA, you can see the humongous dimension of the data they are dealing with, and they don't have any other option actually apart from dealing with this much of traffic. This is what they do. And you can also talk about one of the hubs of data, which is Google, and their current storage is 15 gigabytes, 100 petabytes processed per day, 60 trillion number of pages indexed, and trust me, that's data as well. Unique searches per month greater than 1 billion, 2.3 million searches per second, and that's just the tip of the iceberg actually. And there's so much words there, but the entire gist of this, including this particular graphic, is that people say that the data is increasing and incoming every second year. The world's data is going to double. But what has caused this particular data to double and double again, and it's growing exponentially? The kind of data that we used to deal in the past, that probably is not increasing at an extent which is as alarming as the overall data. The part of data that's increasing is actually unstructured data, and one of the reasons behind it is that the number of devices have increased. We have so many different information sources. Don't forget, we are living in a selfie age. Every now and then people are taking the pictures. That is data. People uploading the videos to YouTube. That's data. Everybody has got phones, be it Android, iOS, or whatever it may be. they are generating data day in, day out, and that is unstructured data. Just to quickly tell you what is unstructured data, structured data, and semi-structured data, which are precisely the kind of categories in which I can divide the data in. So structured data is very similar to what we talked about in the past. The data which has got a schema, right? Something that we can relate, something which has got a structure. Think of a table which has got 3 columns. One first is employee ID, second is employee email, and third is employee name, right? Whatever data is going to come in that container, is going to come in that particular structure. That is structured data. But trust me, it's a very simple definition of it. Semi-structured data relates to something which has a structure, but within the details, its format can change. A classic example of that can be an XML file or a JSON file or something like that. But when we talk about unstructured data, we're talking about data which is like voice data or images data or videos and all that stuff. Because classically, these are binary data. They don't have any schema, they don't have any structure, but they have a lot of hidden intelligence in that. And that's precisely the kind of data which is increasing at an exponential rate here, which is causing tremendous amount of stress. And that's not a kind of data which the world can ignore, right? See, I'm also making my share of increasing the unstructured data because I'm quite sure this presentation is also getting recorded. So that's my contribution to the increase in the unstructured data of the world. Thanks to technology, right? Now, just to understand big data from a technology standpoint, not entirely though, but this is how IBM defines the big data, and trust me, this time the entire world agrees to it as well. Largely, the big data can be divided into, following acceptance criteria, if I may say so. Volume is one thing that we talked about. The data has to be, extortionately bigger, in order to qualify as something which is, a big data problem. Petabytes, terabytes, zettabytes, and all that stuff. The second V, popularly they call it 4 Vs, right? So the second V, velocity, is if the rate of generation of data or the accumulation of data is high, right? That is the way you denote that is the velocity, and the understanding is that any such data which is large and is getting produced with a tremendous pace, that is a feature which confirms to it being called as a big data. Third thing is that it has to have the variety. The data necessarily may not be in one form, like I told you, the difference between structured, semi-structured, and structured. Data can come in all the forms: weblogs, sensor data, images, videos, and audios, and there are a number of other formats as well, right? And the veracity, and I believe this is very, very important. A recently added V, and what it means is that we cannot take a data which is not trustworthy, which is not from the genuine resources, because sometimes what happens, we have programs and we have applications which can produce, data on its own. So the authenticity of data is something which has been emphasized out here. And there's a lot of research going on as to how to truly define big data, and a lot of different V's also coming. Medona also is presenting one V from her side. Then I'm sure the technology is going to be even more interesting, actually. So these are essentially the big data system requirements. Like I told you, it should be, there are plenty of frameworks actually. So in all the frameworks, they have to have, the following requirements. They should be able to store data. They should be having the capability to actually process the data. And they should also be flexible enough to actually scale the data, because the amount of data can increase actually. So in future, the scale increases, that particular system or ecosystem, a big data ecosystem, should be able to actually scale itself up, right? We'll move on to the next slide. So, considering all the complexities that I told you, which relates to the processing and the scaling and the storage and the different kind of data and the velocity and all that stuff, a traditional data technology that we spoke earlier probably won't be able to cut it anymore, right? So that's the entire idea of explaining you the complexities, was to make sure that under these kind of circumstances, you probably have to move down to the big data itself. And one of the most established may I say, the big data system rather. There are a couple of others as well, but Hadoop is the best example if we have to walk over what the big data system is all about, right? And it conforms to all those three requirements that we mentioned. Hadoop has got the capability to store any kind of data, and of any scale and of any variety, and it has the capability to actually process that particular data as well, and it has the capability and flexibility to scale itself if the case requires it to. So it's a framework that allows for distributed processing of large data sets. How that is distributed, we're going to talk about it very, very clearly. Just watch this space. And just to mention, it's an open source data management tool, which means a lot of developers from around the world they contribute to its development, and it's currently under the Apache Software Foundation. And if you're more interested in reading about it, probably there's a Wikipedia page in there. You can just click on it to understand, because we're anyways going to understand how it works actually. So let me just grab some water. So this is how, it's important to understand. In order to understand and appreciate the true power of Hadoop, we need to understand, how it's being made, right? So there are two ways to build a system. One is monolithic, and another one is distributed. When I say monolithic, I'm talking about a system which can, which is like a very smart star player, who can dribble and can shoot. It's almost like, a single solo Iron Man kind of guy, actually, when he can do any damn thing. And in the technology parlance, probably it can correspond to a very powerful server, which has got extremely spruced up memory, hard disk, processing power, too much of network bandwidth and all that stuff. But you will agree that these kind of systems often have their limits, pretty much like the player who might be powerful, but he's single at the end of the day. And there's another methodology in which you can create a system which has got a combination of too many not so smart kind of machines, but they together parallelly can work in parallel, right? And that's called distributed way to build a system, analogous to a lot of players, good players who can pass well. And it's important to understand this philosophy, because this is how Hadoop is being made as well, right? Just the clarification of some of the terms, because this is the term that I'm going to use a lot. Cluster. So a combination of the individual systems, right? Forms a cluster, right? And the individual node, individual computer, or rather server, right, is called the node. So what happens is, in order to create a Hadoop cluster, what we do is we stack up a lot of commodity servers, which are like typical rack-based servers. Every company has got too many of them. We can put them to work alongside in parallel to create a cluster, which forms the basis of Hadoop itself. And that's what most of the companies are doing. Companies like Facebook, Amazon, Google, all these companies are creating vast server farms. And I can remember Yahoo has got 40,000 odd nodes cluster actually for processing the huge data sets. But it's important to understand that while we have created a cluster of so many individual nodes, they're not going to work until there is one single coordinating software, right? So think of this software as a master, and all the individual nodes which collectively form the cluster as slaves. So very popularly, systems like Hadoop, they're called master-slave architecture actually. Now let's understand what the single coordinating software does actually. Because we're talking about huge data, we need to partition the data as well, so that we understand that, well, what sort of data is kept where, So that's being done by this single coordinating software. When we have to process that data, we have to, we have to collectively use the resources of all the individual nodes, and we have to run the jobs on specified data, which is distributed across all the nodes actually. So somebody has to coordinate the computing task in simple words, somebody has to understand that I want to run this particular job on this data kept in these nodes, and I want to see whether those nodes are alive or not actually, right? So, right. One of the important thing is that, we should also be able to have, right. One of the things is that the good thing about this is that because we're going to use the cheap machines, the normal commodity rack-based servers, there's a chance actually that one of them is also going to get faulty. But these Hadoop systems, or for that matter, these distributed systems, are designed in such a way that even if one commodity hardware fails, the other can take. And the reason why they're able to do, because every data they replicate more than 2 times or 3 times by default, but that's configurable actually. But it's important for you to understand that there's a tremendous fault tolerance. You're not going to miss out on the data, so you're not going to miss out on the processing as well. So you're not going to miss out on the business intelligence as well. Fantastic, right? So the net takeaway is that it's a master-slave architecture, allows you to process the data, store the data in a parallelized manner. That's why it is powerful. That's why it can be scaled, right? The way it happened is that Google actually did this particular thing because they were the first one, logically so, to deal with a huge data set, right? And they had to store the data, so they created a Google file system. They had to process the data. They created a programming environment, which is called MapReduce, based on the same concept that I talked about, parallel processing, right? Very simple, right? Now, and then once they reached a logical end, they contributed the entire code base to Apache Software Foundation. Apache took it up, opened the doors for all the developers from around the world. They called the programming environment part, which was MapReduce, on your right. They called it MapReduce, precisely the same what Google called it, but they changed the name of the file system of Google, which was Google File System, to HDFS. So HDFS for storage, MapReduce for processing, collectively formed Apache Hadoop. Till a new member came in, which was called Yarn, in the dark orange in the middle, right? So we'll quickly go, so we understand what MapReduce is all about, which allows developers to write the programs to decide how we're going to process the data. So what they do is they define the map and the reduce task using the MapReduce APIs and triggers it. In simple words, how do we process the data in a human way as well? If somebody asks us to actually process the data, we first of all go as divergent as possible to open up that problem, and then we go as convergent as convergent as possible in order to get some results out of it. You can think of map and reduce precisely the same thing actually. So map allows you to open the data in order to analyze and reduce, then finally reduces to a final result actually. So that's what MapReduce is. HDFS, we all know what it is. It's a simple distributed file system which allows you to keep the data in, on our different nodes and still keep track of what is kept where. Yarn is something which is like a pop-up thing actually. It knows where the data is kept. It knows how many nodes we have, how many nodes are alive, which node have got the memory alive, which node has got the hard disk remaining and the processing stuff. It knows everything. So basically, it's the heart of the master, right? That's something which runs the show. So these are the primary components of the recent version of Hadoop, with Yarn coming in the MapReduce and in the Hadoop 2, right? And I'm sure you can grab more details of that. Hadoop is such a comprehensive ecosystem that probably we can end up reading about it for probably 6 months or so. It's important to understand that it's distributed. And it also contains following components. Every component has got its own essence. And in the interest of time, I'm just going to give one liner, but I'll try to explain it as transparently as possible. MapReduce is a difficult thing to write. It's not one of the easiest things to write. That's why the developers who were dealing with the databases earlier, before scale intimidated them, using SQL and all that stuff, they got scared. I should not use the word scared, but they got intimidated actually, when they were exposed to some of the most complex way of programming. So in order to make their life easy, companies like Yahoo and Facebook, they decided to create an abstraction so that the developers can still write their transformation queries in SQL, and internally they get resolved to MapReduce, right? So Yahoo went on to create Pig, and Facebook went on to create Hive. It's as simple as that, right? So it means that using Pig and Hive, you can run all those transformations in a distributed environment using some of the statements which are pretty similar to SQL. So that's how they made the life of their developers easy, and then they made the life of people like me easy as well, right? Because I learned them and I do it. Okay. HBase. Think of HBase as a NoSQL, right? Flume and Scoop is something which allows you to bring in the data and take the data out. You have to bring in the data for processing, and once you process the data, you have to move it out as well. So those are like messaging things actually. Spark. I'll just go back. Right. So Spark and Oozie, there are some other components, but it'll take a while for me to explain. Spark is another way you can process the data, but using in-memory techniques. And Oozie is something which is like a scheduling engine. So sometimes you have to run jobs which are too complex, and you have to pipe them up actually, right? And there are many common big data application scenarios. You can go through it. Plenty of examples. eBay uses that. Recommendation engine, Verizon, of course, it's dealing with the calls all the time. So there are plenty of information, and there are so many different use cases in which they end up using the big data, right? Same as the case with NextBio, JP Morgan Chase, and trust me, these are only a few examples. There's hardly any company actually which is dealing with it. Right. So this is the final section, which is data learning solutions, it's important to understand that it's one thing to acquire the data and deal with the problem of too much, and then you're able to process that as well and get some intelligence out of it. But the true power of data comes in when data takes care of itself and it helps the system learn like a human being. So in case you're not able to connect to what I'm saying, let's get into the details. Right, I want to go to the next slide. Right, right. So I'm just going to drive you there in an easy to understand manner actually. If you talk about Amazon and Netflix, these are the services we love to use. And why so? Because they are like, our alter egos. They know us like our wives itself, and trust me, I'm not going to talk more about it, but this is close, right? This helps us, and we love them. I can't imagine living my life without Google Maps. And why do we love to use them? Because they are almost indispensable for us. They help us, and obviously, they help us in a way that we want them to help. They help us, Right, and the third one, yes, another example is that, our life would have been really, really difficult if there was no email system which could have separated the information from all the fluff that we keep on getting from so many different people, right? As you can see, there is a clear, classification of important messages from the spam, right? All these examples and a lot of innovations that are normally ushering in, it's not difficult to imagine that machine learning is the invisible hands behind all of this. These are not happening, as a standalone technology. They're all connected by this common factor, which is machine learning. And we're going to take this opportunity actually to talk something about it. This is rather cryptic definition for that. Seems like a bit of English. Machine learning is a method of data analysis that automates analytical model building using algorithms that iteratively learn from data. Machine learning allows computers to find hidden insights without being explicitly programmed. Right. Let's understand what is this in a simple way, actually. Right. I think in order to understand and appreciate the true power of machine learning, I think we need to draw some parallels between machine learning and human beings, and I think hold through the next slides. I'm going to keep on drawing that parallel. Just the way human beings learn, we also create some of the systems where the rules are not explicitly written, but those rules get formed based on the kind of experiences that machine gets and when I say experiences in the technology world, we can understand experiences as data, pretty much like a human being when he is a child. It grows based on experience, and that's how his belief systems get mature, right? So right. So when I talk about experiences in the human form, that you can safely correspond with the data that an application comes across. That experience can be a user clicks for the views. It can be the past question and answers when you talk about the data which is coming from the likes of Stack Overflow and Quora.coms and all that stuff. It can be like users' past travel data in order for you to enable usage of Google Maps and all that stuff. These are all the experiences which we feed to a machine, and that machine grows pretty much like all the human beings grow actually. So there, in these kind of systems, the rules are updated automatically based on data, right? Very much like we all human beings are susceptible to formation of beliefs and also change in the belief system owing to the kind of experiences that we have, right? That's exactly what machine learning is all about. Now, this is a typical machine learning workflow where what we have to do is we first of all have to pick the problem, represent our data, and apply an algorithm. What it means? It means that when we identify with a problem, we have to understand what sort of problem is it. Is it a classification problem? Is it a regression problem? Or is it is about making some kind of recommendation? Or is it a clustering problem? We're going to visit each and every one of those problems in details, probably, and then you'll be able to understand a bit more. But then, once we've decided that this is what the problem is all about, then we have to feed the data to an algorithm which we assume is going to be the best solution for that, right? And the middle part, which is represent your data, is the entire process of bringing a truly chaotic data in a form which can be provided as an input to the algorithm. Because usually the data is dirty, it is everywhere. So we have to slice and dice and process and modify and make it in a form which can then be consumed by an algorithm to give us that kind of behavior, right? So let's visit each and every step of that machine learning workflow. So these are classically 4 buckets, and this is quite an accepted classification of most of the problems that machine learning world normally encounters with. Either the problems are going to be belonging to the classification, regression, recommendation, or clustering. And right, and then, like I told you, represent your data. Data is going to be in different forms: the unstructured data, images, and videos. The problem is that, just for information, this step of the machine learning workflow is something which consumes 80% of our time. Once we sorry about that. Once we understand the problem, and once we understand what is the algorithm that we have to run over these things, the majority of the effort is going to be in bringing the data to the form where it can be fed to the algorithm, actually. Right, and the third one is applying an algorithm. And it's very simple to understand that when we provide the data to that algorithm, it kind of forms a belief system, right, which is what we call as a model. Right, and there are plenty of such examples. We can safely assume that the customers who spend the most amount of money in my superstore are my best customers. So that's the initial updated rule that I might freeze in my brain, right? But when I provide more data to it, probably the definition gets even more fine-tuned and all that stuff. So it's an iterative process with more and more data coming in. The rules keep on getting updated, and that results in a model in which I can provide the newer data to get the information out. So that's what this is all about at a high level, actually. Like I spoke about the types of machine learning problems. We're going to visit them one by one, actually. So when I talk about classification, it's always going to be in the form of questions, right? Whenever you have a problem in the form of question, you can safely assume that it might be a classification problem. For example, that is this email spam or ham? Sentiment analysis, is this tweet positive or negative? Is this day going to be an up day or the down day? Now, if you look at it, in every such question, there is a problem instance. Like in the first case, it's email. The second one is tweet, and the third one it is the trading day. And then we have some of the classifiers like spam or ham or positive and negative and up day or down day and all that stuff actually. There's a way to go about this particular thing. This is one of my favorite topics actually, so chance, and I really would like to spend time on it, but since we don't have too much time left, I'm just going to go over. Right, is there something wrong with this? Right. I want to go back to regression. Right, so the second form is the regression, and it's about predicting the future patterns based on the historic data. For example, some of the problems like what will be the price of the stock on a given date? In order to do that, of course, we'll have to take the past data, plot it, and then find a pattern in the spread of that particular information, find a pattern in that, and based on that, using statistics and mathematics, predict what's going to be the future variation actually. Or for that matter, some of the questions like how long will it take to commute from point A to point B also falls in the same bucket. And again, we'll have to consider a lot of historical data actually. Like for example, if I leave my home at 9 and reach the office at 9:30 every day, so Google Maps do a linear regression to understand that the place where I start from, in all likelihood, is going to be my home, and the place where I reach at 9:30, that's in all likelihood going to be my office actually. So what it does internally is a linear regression. Just to give you a small example, what will be the sales of this product in the given week? Again, falls in the same category. So these are all regression problems actually, just to give you a hint. The third one is the recommendation. Some of the examples for that is what kind of artist will this user like? What are the top 10 book picks for this user? I'm sure that must be ringing the bell, especially for some of the Amazon followers. If a user buys this phone, what else will they buy? So there are plenty of such use cases that you're going to find, especially in the e-commerce space. It's all based on the behavioral study of a user. If 1 million users goes on to buy product A and product B, you can safely assume that they are alike. And if 100 customers out of those 1 million actually buy product C, then you can safely recommend to the rest of the customers that product C. So this is just one small example which I can give you, right? In order for you to understand this complex topic. I'm not going into the mathematics of all these things. I really wish I could, but there's a lot of stuff available actually, and I would be happy to answer your questions in case you want to detail it further. The final one, which can be categorized as a machine learning problem, is clustering, right? And it's nothing but division of, clustering means grouping. Clustering means formation of the groups which are based on some sort of logical deduction. For example, you'd like to, divide your social media users into the groups for effective advertising, maybe for the age, for a certain kind of liking, or for a certain follow-ups and all that stuff. You can divide the customers into different categories for personalized offers, and I'm sure banks, your interaction with the banks and the telecom providers probably can give you a hint about what sort of algorithms they would be running at the back of it, in order for you, in order for them to qualify you into a certain groups. And once you identify the certain groups, what they can do is they can make a policy which applies to that particular group, and in turn, that can be applied to you as well. How simple. Without it, it would have been really difficult for us to imagine what would have happened. Division of employees into different sections for targeted policies. Once again, it falls in the same group, actually. And there are plenty of use cases which are based on the same sort of use cases, same sort of problems that I discussed, and same sort of algorithms. But this is not even the tip of the iceberg. We're not even scratching the surface here. Machine learning is quite applied in variety of business problems, and going forward, it's going to be one of the major indicators of the innovation, actually. You can go through it. Right, and see, it's the first line sums it up. It says machine learning is complex, but so are human beings. What we are trying to do is we are trying to draw parallels with human beings, right? And we are making applications which can behave like human beings, which can talk like humans, sorry, not talk, behave like human beings and perform like human beings, and which is not a simple thing actually. So, at times it becomes complex, and this is the single most happening thing at the moment, and all the bigger companies are putting the stakes there. And in case it arrives to you as a complex thing, actually, trust me, with patience, it's going to start making some sense gradually. That's right. Right. So I think that's pretty much it from our side. And I'd just like to tell you that we are a part of a team actually, which is working on some exciting solutions for clients from different verticals, and especially in the fields of image analysis and video content analysis, and the clustering algorithms, primarily in the space of retailing and the queue management and the heat map analysis and all that kind of stuff. If I get an opportunity actually to talk with you, actually, I mean, we can detail more about it. So that's pretty much it from my side. Sarah, you want to take it over?
Hi, Praveen. Yes, thank you so much. We do have a couple questions for you, and a couple of the audience has a few questions as well here. So number one, according to you, what would be the biggest challenges and opportunities related to future trends in the world of data?
Oh my God, it's not a simple question to answer because one of the biggest problems is the change in the culture. We're talking about big data, right? There are some companies like Google and Facebook, they've taken their data quite seriously from times immemorial, right? They understood a bit early in the cycle that data is a hot property, it's an intellectual thing. But there are a lot of companies who are generating a lot of data but simply don't have the means to capture that. Now, first of all, they need to actually create a shift in their culture so that they respect the data, they capture it, and only then all the magic that I spoke about, all the different technologies can work on the top of it. I think that's going to be the number one challenge. And the number two challenge is going to be that with the advent of these technologies, we are asking about different kind of human resources. We are talking not just about programmers, we are talking about some of the scientific computation programmers, and there's a huge skill shortage for that. So unless there's a team which has got the expertise and experience of multiple implementations, chances are that such a bigger step, which is going to involve a lot of cost, may probably be a risky proposition. So that's also one of the big challenge, actually. So. And
great, thanks for
yeah.
Perfect. Okay, and just due to the interest of time, you want to be respectful of everyone else's time as well. So we're just going to ask one more question for you. How can an organization know if machine learning and AI is for them?
Right. I think it's a rather simple question to answer, actually. I think, right. If any organization is making too many human judgments, then I think that organization must certainly involve machine learning, because you can be a smart retailer who's got 25 years of experience, and you've seen too many winters and too many summers. You have a fair bit of idea that in the coming summer, this kind of cold drink is going to be in demand, and you can probably throw up a figure to sound like a person who makes excellent decisions, but there's a lot of risk in doing those kind of in making those kind of decisions, actually. But what machine learning can do in those kind of situations, it can augment those fantastic experience-based judgmental decisions with the backing of mathematically calculated, statistically derived, data-driven decisions.
Great, thank you so much, Praveen. And I just want to thank everyone